Your next computer might cost you a few $100s more than it should. Not because the technology got better. Not because parts got more expensive. But because last week, a document that was never supposed to leave AMD's internal servers ended up on the internet for anyone to read. AMD makes the chips inside nearly 1 out of every 5 computers sold worldwide. This document laid out their entire roadmap for the next generation of desktop processors. It was meant for internal teams and a handful of partners. A researcher found it, screenshotted it, and posted it to X. It was publicly accessible for only a few hours before AMD quietly pulled it down. But those few hours were enough. Because buried inside the document is a decision that directly affects how much you spend on your next PC and what happens when that PC goes wrong. And behind that decision is something even bigger, a secret war between 3 of the most powerful tech companies on the planet. A war that's already decided what your next computer is going to look like, whether you knew about it or not. So what exactly was in that document? Most people assume that when a chip company releases a new product, the deal is simple. Better performance, lower price, better computer for you. That logic makes sense. And for most of tech history, it's been true. But if you actually read through what leaked last week, something immediately feels off. AMD isn't just adding things to their next chip. They're deliberately removing something that users have relied on for years. Not because they can't include it. Not because users don't need it. But because something bigger is forcing their hand. What is that thing they're removing? What's forcing them to do it? And who actually gets hurt when it's gone? Let's start with the basics. Every computer has a processor, the chip that runs everything. Think of it as the brain of your machine. Inside that brain, there's a small module whose only job is to make sure your monitor can display an image. It sits there quietly in the background. Most of the time, you don't even know it exists. Here's when you would know it exists. Imagine your computer crashes. The screen goes black. Your graphics card, the separate component that handles visuals for gaming or design work, has just failed, or its software has corrupted. You're staring at nothing. That small module inside your processor is the only thing that can bring your screen back to life. It lets you get back into your system, reinstall drivers, recover files, figure out what went wrong. Without it, your computer is a very expensive paperweight. You can't troubleshoot it. You can't save anything. You're just stuck. Think of it like the spare tire in your car. You never think about it. You hope you never need it. But the one time you get a blowout on the highway at night, it's the only thing standing between you and being completely stranded. AMD is removing that spare tire. And in its place, they're installing a self-driving sensor system that most drivers will never actually use. The spare tire is called an integrated graphics unit. The self-driving sensor is called an NPU, a chip designed specifically to run AI tasks locally on your computer. According to AMD's own technical documentation, the document that leaked last week, their next flagship desktop processor, codenamed Olympic Ridge, is expected to launch in 2027. It will be the first AMD flagship desktop chip in nearly a decade to ship without integrated graphics. So why would they make this trade? Is there something forcing their hand? Why remove integrated graphics? To free up space for the NPU, the AI chip. Why does the NPU need to be there so badly? Because Microsoft issued what amounts to an ultimatum. Microsoft makes Windows, the operating system running on more than 70% of the world's computers. They've announced that the next generation of Windows PCs must meet a minimum threshold of local AI computing power to qualify as an official AI PC and unlock a full suite of upcoming AI features. Think of it like a building code. If your house doesn't meet the standard, you don't get the certificate. If a chip doesn't meet Microsoft's AI requirement, PC makers won't prioritize it when building their next lineup of computers. And if PC makers don't prioritize you, your sales numbers start falling. So every chip company right now is racing to stuff as much AI computing power into their processors as possible, just to stay in the game. Okay. But why can't AMD just include both, keep the integrated graphics and add the AI chip? Because space on a chip is money. Literal money. Here's how to think about it. A processor isn't just one piece of silicon. Every feature, every function, every module takes up physical area on that chip. The more area you use, the higher the manufacturing cost, and the lower the yield, meaning fewer chips come out working correctly from each production run. AMD's next generation is being built on TSMC's 2nm process, currently the most advanced chip manufacturing technology in the world. Industry data puts the wafer cost for this process at around $30,000 per wafer. Every square millimeter of chip area is genuinely expensive. Integrated graphics takes up meaningful space. On a high-end desktop machine where almost every user already has a dedicated graphics card, AMD's calculation is that space is being wasted. Pull it out. Put the AI chip in. Meet Microsoft's standard. Protect the business. The logic holds together. Until the day your graphics card fails and your screen goes dark. So who actually pays the price for this decision? Most people's first instinct is that gamers get hurt the most. But gamers are actually the least affected group here. If you're gaming, you already have a dedicated graphics card. Integrated graphics was never part of your setup to begin with. You'll barely notice it's gone. The people who feel this most immediately are in a category you probably didn't expect: corporate IT buyers. Picture a company purchasing 150 computers for their staff. Standard office machines, email, video calls, documents. No gaming, no design work. With integrated graphics, you plug in a monitor and the screen turns on. Simple, cheap, done. Without integrated graphics, every single one of those machines needs an additional dedicated graphics card just to display an image. Even the cheapest option adds real cost per unit. Multiply that across a large fleet of computers and you're looking at significant unplanned budget, not because the company wanted better machines, but because a feature was removed. That IT buyer is now seriously reconsidering their vendor. And the company that benefits most from that reconsideration is Intel. Intel is AMD's closest competitor in the processor market. And Intel has never removed integrated graphics from their desktop lineup. Not once. AMD's decision hands Intel a significant advantage in the corporate market, the pre-built PC market, and anyone who needs a reliable, low-maintenance machine that just works out of the box. According to Mercury Research, Intel already holds close to 70% of the enterprise desktop processor market. AMD's move essentially reinforces the wall Intel has already built around their strongest territory. So what does this mean for the regular person buying a computer in the next 2 years? Here's a concrete situation. You're an IT manager at a mid-sized company. You're responsible for purchasing around 150 computers this year, standard office machines, nothing fancy. For the past few years, AMD's platform has been your go-to. It's cost-effective, it does the job, and it's helped you come in under budget every cycle. Then this news breaks. You call your supplier. They confirm, if the next AMD lineup ships without integrated graphics, every machine in your order needs an add-on graphics card to function. The cost per unit goes up. Across your full order, that's a meaningful jump in total spend that wasn't in your budget. You open your procurement spreadsheet. At the top, there's a field you've filled in the same way for 3 years running. This time, you're not sure what to type. That's what a leaked internal document looks like when it lands in the real world. So where does all of this go from here? This leak isn't just about one company's product decision. It's pointing at something structural happening across the entire PC industry. For decades, the competition was simple. More cores. Higher clock speeds. Better benchmark scores. Consumers could compare numbers and make a call. That era is ending. The new competition is about software ecosystems, AI integration, and who gets to define the standard that everyone else has to meet. Microsoft sets the AI PC requirement. Chip companies race to comply. PC makers build around whoever complies best. And consumers end up with whatever that process produces, whether they asked for it or not. This shift is not going to reverse in the next 3 to 5 years. But here's the variable that could change everything. Multiple credible tech outlets have reported that Intel and Nvidia, two companies that have spent years competing aggressively against each other, are secretly collaborating on a chip codenamed Serpent Lake, with a reported target of early 2028. Nvidia makes the world's most powerful graphics technology. Intel makes processors. The reported goal is to combine both on a single chip, meaning a laptop or desktop could ship with full Nvidia graphics capability built in, no separate graphics card required. If that product ships, AMD's single greatest advantage, the ability to integrate strong graphics directly into their processors, gets neutralized by two of the most powerful companies in tech working together. But here's what has to be said clearly. Neither Intel nor Nvidia has officially confirmed any of this. The gap between a leaked roadmap and an actual product on a store shelf is enormous. Engineering challenges, manufacturing capacity, and the complexity of two major companies aligning their interests can derail even the most confident-looking plans. AMD's own FSR 4.1 update, a software improvement for older graphics cards, was delayed by nearly 2.5 years from its original timeline. That's not ancient history. That happened this year. Roadmaps are optimistic by nature. Products are not. Next time you see a tech company announce a new product, a new feature, or a new roadmap for chips, phones, laptops, anything, ask yourself one question. Between the slide deck on stage and the actual product on the shelf, how many things have to go perfectly right for this to actually happen? Answer that honestly, and you'll know whether to buy now or wait.